Hi, Assalamualaikum warahmatullahi wabarakatuh. This is our video presentation for PHY150 and our main topic is electrical transportation. So, before we go through the topic, let me introduce our group member first. So, this is our group members, which is me, Muhammad HARIZ bin Muhammad AFFANDI, Ni HAIDDIN bin RUDZIHA, Nur FARHANA binti ZAINAL, and lastly, Nur FITRIANI binti RAZLAN. So this is our table of content for this video, which is the first is introduction of transportation and significant, electricity magnetism concept, benefit of electrical transportation, challenge of electrical transportation, future development, and lastly is reference. For the introduction, in the late of 19th and early 20th centuries, the early development of electric transportation was intimately tied to the principles of electricity and magnetism. Engineers and inventors harnessed these principles to create the electric motors that powered early vehicles. Electric trams and trolleys, for instance, operated by delivering electric power through overhead lines, showcasing the direct application of electromagnetic forces. These shifts mark a departure from traditional transportation reliant on fossil fuels, laying the groundwork for the electrical vehicles we see today. The understanding and application of these fundamental principles remain integral as electric transportation continues to evolve, emphasizing the enduring impact of electricity and magnetism on the way we move. For the significant, firstly is power generation and distribution. In the realm of power generation, electrical transport is the catalyst converting various energies into electricity. Here, the principles of electricity and magnetism converge in generators and transformers, which is optimizing energy conversion and distribution. Next is electronics. As we navigate the world of electronics, electrical transports, power circuits, and the principles of electricity and magnetism underpin key components like transistors and inductors. This synergy enables the devices that define our interconnected digital age. And next is renewable energy. Renewable energy solutions relying on solar panels and electric vehicles, which is showcase the intricate collaboration of electricity and magnetism. The sun's energy is harnessed through electrical transports, and magnetism propels electric vehicles into a sustainable future. And lastly is technology and medicine. Beyond this, our journey extends to technology and medicine, where the combination of electricity and magnetism is pivotal. A magnetic resonance imaging, which is MRI, machines exemplify this synergy, providing detailed insights into the human body.
Hi, my name is HAIDDIN and I'm going to talk about the electricity and magnetism concepts. Electricity and magnetism form the basics of electrical transports. Electricity provides the energy that powers electric vehicles, while magnetism is used in electric motors to convert electrical energy into mechanical energy. The interaction between electricity and magnetism enables the movement of electrical vehicles as well as the charging process. First, the electricity. In electrical transports, electricity is used to power vehicles such as cars, trains, and buses. These vehicles are typically powered by electric motors which convert electrical energy into mechanical energy. To propel the vehicle forwards, electric motors work based on the principle of electromagnetism, while magnetism utilized in charging infrastructure for electric vehicles. Charging stations typically rely on electromagnetic induction to transfer electrical energy wirelessly from the station to the vehicle. This technology utilizes coils of wire to create a magnetic field which induces an electric current in a corresponding coil in the vehicle and charging its battery.
Next, the exploration of electrical transport application and technology. So the first is battery management system, BMS. One of the function is to measure the voltage and temperature. When electricity generated in a battery, electron moves through the circuit and produce voltage. BMS continuously monitors the voltage of the battery cells using specialized voltage sensors and measure the temperature of the battery by temperature sensors to maintain the ideal temperature range. The second is Advanced Vehicle to Everything V2E. The function have two, which is to transmit power wirelessly between the electrical device and enable the electrical vehicles to communicate with their surrounding environment. But how? It is by harness energy from electromagnetic spectrum to generate electricity while driving. Next is electromagnetic compatibility EMC. By using electromagnetism and electricity concept, this ensures the optimal performance and efficiency energy transfer for sustainable power distribution and enhanced system performance. Power line communication (PLC) is the technology that allows the transmission of digital data by modulating the voltage or current in power line using electricity and magnetism concept for accuracy in transmitting and receiving data.
Next, I'm going to talk about the example of real-world implementation of electrical transportation. The first one is electric car. When we talk about the electric car, first thing we talk about is a Tesla, right? So basically, these cars are powered by electricity instead of traditional gasoline and diesels. These vehicles utilize electric motor technology to convert electrical energy into mechanical energy to propel the car forward. The second one is electric buses. These buses rely on electric motors and large battery packs to drive the wheels, eliminating the need for fossil fuel consumption and reducing carbon emissions. Electric buses are often charged overnight at depots or at special charging stations throughout the day. And the last one is electric scooters. This mode of transportation are eco-friendly alternative to traditional scooters or bicycles, as they rely on electric motors, batteries and pedal assist system for propulsion.
Benefit of electrical transportation. The first one is environmental impact. It is significantly to reduce greenhouse gas emission. The second is lower operating costs, which is electric vehicle owner may benefit from lower electricity rates during off-peak hours. The third one is reduced dependence on fossil fuel. Shifting to electric transportation reduce the demand of these limited resources. The fourth benefit of electrical transportation is improve air quality by reducing pollutants that harmful to human body. The fifth is energy efficiency, which is electric motor are more energy efficiency than the internal combustion engine. The sixth is health benefits. Health benefits, we can improve the public health outcome by minimizing exposure to the harmful pollutants. However, there are some of challenging for electrical vehicle. The first one is upfront cost and affordability. The initial purchase price of electrical vehicle can be higher than the traditional vehicle. The second is limited the charging infrastructure. The availability of charging infrastructure may be insufficient, especially for the certain countries such as India or Africa. The third is charging time. Time is taken to charge an electrical vehicle is generally longer than refueling a traditional vehicle. Impact convenience for user. The last is recycling and disposal concern. Proper recycling and disposal of used batteries present challenge as the process need to be managed to minimize environmental impact. For the future development for electrical transportation, we can conclude that we need to increase range and battery technology by improve battery technology by offering increased energy density and longer driving range on a single charge. The second is affordability and market access. As the cost of electric vehicle decrease, they become more price competitive with traditional internal combustion energy vehicle, making them more affordable for customer. And the last is to improve the innovation in battery recycling. We will increase the focus on efficiency and environmental friendly battery recycling method.
In brief, the relationship between electricity and magnetism is crucial in electric transport or fundamental in every aspect in electric transport, including in electric motors, in charging, brakes, and any other component. For example, trains and electric cars are most common electric transportation that use electricity and magnetism concepts. Electrical transportation also help to reduce pollution and promoting clear air into our earth. It can utilizing energy more effectively, and these concepts enable the development of advanced electric vehicles that can revolutionize the future of transportation.
Thank you all for joining today's presentation on electrical transportation. I appreciate your interest in these important and evolving fields. Your presence means a lot, and I appreciate your time and attention. Thank you.